Hey everyone, thank you for attending. I'm Jim and we'll be talking about Kyverno and policy management today. So just, kind of to set the context on this topic and cloud native in general, as many of you know, obviously there's a lot of interest today in cloud native architectures, cloud native applications, and some of the underlying tech for this. But what really drives this, and it was interesting, there was a study I was reading, a report earlier today, I believe it was from VMware on, it was the state of Kubernetes 2021. And it talked about how almost 98% of folks who use Kubernetes uh, see value, which is an awesome number. It's a very large number if you think about any technology that we've used in the past and how many people actually see value from that. 98% is a fantastic sort of bar, and Kubernetes is achieving that, right? And some of the value, some of the things they talked about is just being able to deliver faster, being able to increase efficiencies, whether it's sort of efficiencies of resources through automation, or even efficiencies in terms of processes and in terms of DevOps, overall, both from the tooling, the people point of view as well. And more importantly, improving the overall customer experience, right? So whatever your business is delivering to your end users, to your end customers, improving those experiences. So certainly that, is, if you couple that with some of the data we're seeing from CNCF, it's amazing to see there's almost like a 300% plus growth in terms of production Kubernetes deployments just in the last few years. And that trend is continuing, even to tick further upwards. But at the same time, the thing that's always looming is everybody acknowledges there's quite a bit of complexity or perceived complexity in Kubernetes, right? And also security tends to be front and center in terms of being able to secure Kubernetes deployments, being able to adopt best practices across workloads, across cluster configurations, things to that nature. So those topics are what we're going to talk about today. And I guess the main point of this presentation, if any, is that policy management and policies can help address both of these large concerns. When we're talking about complexity, when we're talking about security, in many domains, you hear about policies, and here we're not talking about policies just in terms of regulatory compliance and things like that, but actual automation, right? Things which can help us do our jobs as DevOps practitioners, make things easier for our users, developers, as well as anybody else using the system through policy management and being able to get the right data back from the system in terms of what's required for compliance and governance, right? Yeah, so this is data from that report I was quoting earlier, and it's interesting because it backs up what I just mentioned, is where they talk about 97% of Kubernetes adopters are still, there's a fair amount of concern about how to secure, how to manage things. And the other interesting point here is that applying policies consistently, they ranked #1 in terms of the security domains, or in terms of the different criteria, and then being able to do things like secure workloads, again, configurations, as well as images, those round out the top 3, right? So all 3 of these are things we will cover today, and we'll see especially how Kyverno, the open source tool, which is a CNCF project as well, that we'll talk about, addresses these. So Drew already introduced myself, so I won't go into more details, but feel free to, if you want to reach out and connect with me. I'm at Jim Bagwadia on all of the typical social media networks or channels, and as well as on the Kubernetes Slack. If you are part of the Kubernetes community, you can find me there on the Kubernetes Slack as well. So some of the topics we'll cover is, first off, what is, in the context of Kubernetes and cloud native, what is declarative policy management, right? We all hear about these terms. So we'll dive in and kind of dissect that and level set on what that means. Then we'll do an introduction to Kyverno. I'll talk about Kyverno versus oppa gatekeeper. Oppa gatekeeper, for those of you who may not know of it, is another CNCF project which also addresses similar concern. But there are key differences that we'll highlight about when to choose Kyverno or when to use oppa gatekeeper. We'll talk about pod security because that's certainly a topic of interest to everyone. And pods, as you may know, are the fundamental unit of deployment and operations in Kubernetes itself, right? And then we'll go through some demos, and based on time, we can we'll do Q&A as well as any other topic that needs to be discussed. All right, so let's dive into what Kyverno is and how it kind of matters. Actually, before that, let's talk about what policies and declarative policy management itself means, right? So in a very broad sense, policies are something that multiple parties agree to, right? And in our case, when we're talking about Kubernetes policies, our concern is between developers and operators. Typically, it's a platform team, it's an operations team that runs the cluster and runs some common services. And developers tend to be the consumers, or product teams tend to be the consumers of these clusters. So really, policies become this digital contract, and it's a codified contract. It's an actual object. It's something, and of course, the best practice here is to manage policies as code. So it's something that you can manage as code, and that exists in Kubernetes. Kubernetes also has some native objects, which are examples of policies like network policies, even some of the RBAC rules and things like that. But here we'll talk about extending that and adding your own custom policies for your organization. So another thing we hear about often is this declarative versus imperative, right? And it's interesting if you're used to programming language theory, these terms are fairly clear in that context. And what it means is there's two ways of writing programs, right? And sort of at some point in time, like I guess it was like 70s, 80s, procedural programming used to be very popular, where you're giving the computer one instruction at a time on how to do things, right? And that is what an imperative API does. There's a lot of flexibility in that approach because you can really the system does some very simple things, but you can write very complex algorithms and things on top of that because you're instructing as a user. You're telling the system step by step exactly what to do. But the declarative style is very different. In there, you're saying, here's what I want as my end result, right? And you go figure out, system or whoever's programmed the system, it's your job to figure out how to do that. But I'm just going to describe my desired outcome over here. So very different styles of APIs or writing programs. And in Kubernetes, you'll hear about Kubernetes as declarative configurations, right? Where you're really defining how you want the end state to look. And in Kubernetes, there's controllers for every major function, which will go off and do what you want. So now translating that to policy management, really what you want is you want a platform team and an operator or an admin to say, okay, I want, this is the kind of thing I want for my system. And then you want that to be implemented across all of your clusters. And ideally, not just across all of your clusters, but even in the CI/CD pipeline, right? So you want the policy to be applied, and especially if you're defining workloads, you are using things like GitOps to be able to push these workloads across your clusters. You want these policies to be defined once in a central manner, and then to be applied across your CI/CD pipeline and across each cluster that's in your production or dev test or your staging environments, right? Now, there might be some variations in these policies as you're applying them, because maybe in your dev test environment, maybe you don't want to block configurations up front, but you want to report on violations. But in staging and production, you may configure your policy engines to block things up front. So that's what we mean when we talk about declarative policy management at a very high level. is being able to specify some desired outcomes, and then having the system. In this case, we'll talk about how Kyverno does this, but it could be other tools, or a set of different tools which are applying this into your clusters in your system. All right, so now let's dive into Kyverno itself and see how we can get to this declarative policy management with Kyverno. So one thing to kind of answer this comes up often is, what does Kyverno even mean? Why was the project named that? So Kyverno, Kubernetes, as a lot of you might know, is a Greek word for helmsman or journeyman. Somebody who drives a ship, who navigates. And Kyverno is a Greek word for govern, right? So because we're talking about policies and governance, that's why we felt it was a nice, kind of word to use for the project, because Kyverno sort of provides that governance into Kubernetes. So it's a policy engine that was built specifically for Kubernetes. Kyverno doesn't, is not a general purpose policy engine, as you will talk about in the next section. If you're looking at oppa gatekeeper, that is more of a general purpose. Oppa is a general purpose policy engine, and gatekeeper is its, what plugs it into Kubernetes for admission controls and other things. But Kyverno is focused on Kubernetes, which comes with some trade-offs, because it narrows things down to, or its worldview is for Kubernetes. It can leverage a lot of the best practices, patterns, and things that are built into Kubernetes, and it is also kind of built to operate in a manner which is very familiar to Kubernetes users itself, right? So if you know what a pod spec looks like, if you know what a deployment looks like, Kyverno policies end up being very familiar because they're focused on Kubernetes resources and Kubernetes itself. So, and the main goal of creating this project, and one of the reasons why it's been, growing fairly rapidly, we're up to like about, I think, almost 4 million downloads the last time I checked, as well as close to 1,000 GitHub stars, and we have, about 40 plus, now committers and other folks working on the project. So growing very quickly and very rapidly. But the main goal here was to make policies easy to write, easy to manage for Kubernetes, and also be able to view policy results, to be able to get to details in a very simple manner. Kyverno can validate configurations, so it can either audit different configurations of any workload, anything in your Kubernetes system, and it can even enforce that. So if you want to block certain things from entering your cluster, you can do that fairly easily with Kyverno. And then it allows you to mutate configurations, which means you can edit things, set defaults, change values. Like, say, for example, if somebody hasn't provided let's say, a health check for their application pod, you can automate that and you can inject that based on the type of pod, things like that. Another interesting use case is to be able to even generate new configurations. And this is extremely powerful, because now what you can do is you can have fine-grained configuration management where you're creating other resources. So if a namespace is created, maybe you want to generate a network policy, role bindings, as well as other resources which provide the defaults, like secrets for your image registries. All of that can be automated now for your dev teams. And when they just request a namespace, this doesn't have to be a manual sort of handoff or done each time, but it can be fully automated. Kyverno supports, because again, it just deals with Kubernetes, any Kubernetes resource. There's no other library or anything else required. It natively talks to the Kubernetes APIs and supports all of the custom resources, etc. And like I mentioned, it adopts, again, like the patterns we see in Kubernetes, like owner references for lifecycle management, pod controllers, which can be used to manage different pods. So those sort of things become native in Kyverno itself. All right, so let's talk about how Kyverno works, right? So first off, you might have seen a picture like this if you're familiar with how Kubernetes works. So whenever there's an API request, and everything in Kubernetes is driven through the API server. So whenever there's an API request, there's a series of different phases that API request goes through. It goes through the authentication and authorization based on RBAC and other settings. It then goes through mutation phase where you have an opportunity if you write custom webhooks, and Kubernetes has a bunch of webhooks that it provides also, which you can configure when you're setting up your system. So, and along with one of these, you'll see Kyverno can also be plugged in. But it will provide, then there's this mutating phase, after which your data gets validated based on the API schema that you have specified for your resources. Then there's a validating phase where you can again have multiple webhooks, and only after all of that is passes, the data gets persisted to etcd, which is the persistent store in Kubernetes. So Kyverno plugs right into this admission control path, and it will get mutating as well as validating webhooks, and then the policies you write will get executed at the right phase. So if you're doing a validate, it will be at, during the validation phase. If you're doing a mutate, it's in the mutation phase. And if you're doing a generate, Kyverno does something interesting. It will actually record that during the validate phase, but then the generate itself happens only when the resource is created. So again, in the example, if you're creating some custom resources for a namespace, Kyverno will wait till that namespace is created and then just run the generate itself. So here's what a Kyverno policy looks like at a very high level, right? So you have a single policy that contains multiple rules. It can have match and exclude clauses, which are very flexible based on kinds, namespaces, names, different selectors. You can even include user information. So all of this will help you kind of match a policy to an admission request or a resource. And then once that match happens, that policy rule can either mutate, validate, or generate configurations, right? So, and we'll see several examples of these type of policies. In fact, here's one. So here, as you see, match, we're matching every pod. So we're directly, that's in the resources kinds on line 10 and 11. And then, if you look at the actual body of the policy, starting from line 14, what it does is it's saying, okay, I want to match any of these patterns, and if any of them match, my policy will be either kind of applied successfully, or I'm going to deny, right? So if for example, here what we're checking for is that in my pod, which is again what we have specified in the match, either I have run as non-root specified in my pod security context, or the container, every container has run as non-root specified. So one of these conditions has to be true for the rule to pass. And as long as it's, if I've done that at the pod level and then not done, I'm not put false in any of the containers, it'll pass. Or if every container has true, it'll pass. And then this, this pod will be allowed to execute based on whether you put it in audit mode or in enforce mode. So again, pretty simple to read and understand what this policy is doing. And the other interesting thing is, if you know what a pod spec looks like, the lines 15 through 21 are pretty much how a pod spec gets defined in Kubernetes, or it's a fragment of a pod spec, I should say, right? It's not the entire spec, but much like Kustomize, which is another Kubernetes tool, here we are kind of using part of a pod spec to specify how that policy rule should be applied. So there's definitely a lot more, kind of details in what you can do, and a lot more power to different ways to match things. For example, Kyverno can support like wildcard syntaxes, which makes it super easy. Like this particular, validate rule is checking to make sure a label called app exists within whatever resource you want to validate, right? And there's other operators like greater than, less than. So it's fairly, straightforward once you kind of read a few of these to understand what Kyverno is doing, and even start writing policies pretty quickly. And I'll show, the other interesting thing is if you're using Visual Studio Code, or if you're using kubectl, all of the help and syntax and checking is built right in. So again, no special tools required. So Kyverno also, to extend to the syntax, there's other things you can do to kind of, do like an if then else and other types of checks. So here, for example, we're in one of these, the first if then else, by putting parentheses, you're making that a conditional, right? So it's saying if, my port starts with secure, so it's secure and then splat. So if it starts with secure, then the number has to be 6443, right? That's if we want to enforce that, that's what we would do with these few lines. And if you want to say, okay, if the port is not defined, I want to default it to 6443, then you would use a plus, which means just add it if it's not there, right? So very simple, again, conditions that you can add in into your YAML definition to do these type of checks and apply various logic. Here's an example of a generate policy, and this, like I mentioned, would will create a new resource based on certain triggers. So here the trigger could be if my namespace is created, or if some other pod is created, or a service is created. I want to generate some configuration based on that other event. So the generate policy can contain, inline data with which, as you see, again, we're starting from data spec. So this is what a network policy in Kubernetes looks like. And that will, go into a new network policy. And then, or you can also point to an existing resource in your cluster and say, just clone that resource whenever I want to generate a new resource, right? So very flexible, very easy to kind of manage and keep things in sync. Another, very common use case is if I have private registries, I want my, pods to pull or images from, things like that. You might want to copy the registry secrets across in each namespace. So that would be something you would do with a policy rule like this. All right, one final thing to show here is, like I mentioned, reporting in Kyverno is also very native to Kubernetes. So it's very simple. In your namespace itself, you will get a policy report. It will show you how many rules passed, how many failed. You can kind of just with standard command line tools, you can figure out, what the errors are. So if you're a developer, you deploy a workload and you see a bunch of policy errors, assuming that they were not put in block mode, now you can see those errors, you can fix them in your dev test system before you promote that configuration into production, right? So simple way of managing this. So there's several examples, and we'll go through some of those. But configuring probes, configuring quotas, managing image tags, configuring, requiring some certain registries. Pod security is also one key use case, and that is actually, I'll cover that in the next section in more detail. And then of course doing pod security by itself is not enough. You also want to secure workloads. You want to make sure that other settings are correct. Like if you're running, services, maybe you don't want to like allow, external IPs and things like that. There was a recent CVE published on that particular configuration. So those sort of things you can check very easily. You can generate RBAC rules. You can do, if you're sharing clusters, multi-tenancy becomes easy to manage with Kyverno. And also then, managing best practices for labels, injecting sidecars. So there's tons of these type of use cases, and we'll cover, some of the key ones as we look at demos. But let me pause there, and before we go to the next section, let's see if there's any questions we can answer or other things, we want to cover.
Not anything in the chat just yet, but feel free to put something in the chat and we can read it out loud for you as well.
All right. Yeah, and definitely let's keep it interactive. As questions come up, just pop them into chat, and then feel free to also voice them as you think of them.
We've got one in the chat asking for what is a sidecar?
Good question, right? So in Kubernetes, every container runs in a pod. And a pod so can contain a single container, but it can also contain multiple containers. So sidecar is a pattern that's used to describe when you have one main container, like your application container, but then let's say you have another container that's helping with pulling secrets from your secrets management system, like a vault or other external system. Maybe that container is responsible for pushing logs into Splunk. Maybe that container is responsible for managing your service mesh connections, right? So those are called sidecars because they're not, the main application, but they're helper functions which you're putting into your pod for your application itself. Okay, so let's quickly look at oppa gatekeeper versus Kyverno and when you would want to use both one of those, or in some cases you may actually end up using both. So gatekeeper is a Kubernetes project, and oppa, as I mentioned, is also a CNCF project. And what it does is it gives you a way to write policies in a custom language called Rego. And this allows you, it's a very powerful language, but it requires some learning. And what it allows you to do is manage policies in the same manner, whether they're meant for Kubernetes or whether you're writing policies for your own applications or you're writing policies for some other external system.
Hey,
So
Jim.
yeah.
Sorry for the interrupt. We've got another one going back to the sidecar question asking, is a sidecar container used for new plugins in Kubernetes?
It can be, right? So if you want to extend an existing workload, let's say you want to, now introduce some functionality into your existing application, you can, extend that pod spec or that deployment to include another sidecar, or you can inject that sidecar through Kyverno at admission control. The thing to remember though is if you're doing that, there will be a rolling restart of your application because it will pull that new sidecar container, it will restart all of your pods one at a time. So it's not going to create any service outage, but it will be then, the new pods will come up with that new sidecar definition itself. Yeah, so very interesting concept. And if you Google Kubernetes sidecar, there are some examples of the whole pod, like a pattern in a pod where you have like a main application and you have these helper functions in containers running as sidecars. All right, so yeah, just continuing on the oppa gatekeeper versus Kyverno. So if you want to write, and manage policies across multiple systems, certainly the oppa gatekeeper is, something you should look at. There are other tools, like there's a tool from HashiCorp on that, and there's some other options, but that's what those tools do. And Kyverno, on the other hand of it, if you're solving this problem just for Kubernetes, Kyverno, we believe, is a great tool to look at, of course, and see how you can address some of these very common problems in Kubernetes itself, right? The other important thing with Kyverno, as I mentioned, is it's not just about not just about validation and enforcement of certain policies, but also automating things in Kubernetes becomes very key. And especially as you scale your usage, this becomes a increasingly important use case itself. And then finally, because everything in Kyverno is Kubernetes native, you're using familiar tools, you're using kubectl, you're using GitOps, all of those best practices to be able to manage your Kyverno policies as well. And just to kind of make that more concrete, look at examples of what a Kyverno policy looks like versus an oppa gatekeeper policy. So the one on the left, is a oppa gatekeeper policy. And as you can see, it's a JSON-like language that is processing different, blocks, which is, and what this policy is doing, both policies, the Kyverno one on the right and the oppa one on the left, are, validating that your pod in the security context has an attribute called read-only file system, and that attribute has to be set to true. So in the Kyverno policy, as you see, again, it mimics what your pod definition would look like. And in the oppa, this is written in a language called Rego. it's actually parsing through some of these fields and then validating, some checks in the field, right? So again, the idea with Kyverno is to make it simple, make it very understandable for Kubernetes users, and that's why the design decisions are to use the native approach there itself. All right, so let's talk about pod security, and then we'll dive into some demos. And in fact, I'll demonstrate pod security as one of the main use cases. Because if you're running Kubernetes clusters, you definitely want to be using some form of pod security for your production workloads. So there is a Kubernetes object called PSP, or pod security policy. So it's an example of an entry policy, which is part of the Kubernetes API definition itself. But that object in Kubernetes, goes through, everything in Kubernetes goes through alpha, beta, and then GA. And pod security policies have been stuck in beta for quite a long time, like almost 2+ years. And the decision made by the community and the Kubernetes maintainers was it's not going to go to GA, but it actually has been marked for deprecation, and it will be removed in Kubernetes in about 3 releases. There is a KEP. KEP is an acronym for Kubernetes Enhancement Proposal. So there's a KEP to replace PSPs with something which solves most of the problems PSPs solve, but also, acknowledging that there will be other policy engines which will provide more flexibility and other functionality beyond what, pod security requires, right? So this KEP is, the idea is to time it with the removal of PSP. So it will most likely there'll be an alpha version in 1.22, and then after that, the idea will be to move it into GA in subsequent releases. The way it will work is there's another definition called pod security standards. It provides 3 fixed levels of pod security: privileged, baseline, and restricted. And based on using labels, you can mark a label as being privileged or baseline or restricted. And that's what this built-in construct will allow. Now,
Hey,
if you,
Jim,
yeah,
sorry, quick question.
sure.
Talking about Kyverno,
Mhm.
can we use this in production?
Yes. Yeah, absolutely. And we do have customers and several folks from the community using it in production. So it's available, and the spec, the Kyverno policy definitions are, 1.0 GA, right? So it's something that can be used in production now.
Cool, thanks.
Yeah. Yeah, so this KEP will continue to evolve, and as that evolves, Kyverno will also sort of track along, because again, being Kubernetes native, it's important for Kyverno to support built-in constructs and then extend and build on those. The interesting thing here is Kyverno policies, and we have a set of libraries that address pod security. They're all written to comply to the same pod security standards that the eventual entry solution will have. So if you're looking for pods, if you already have PSPs, you should start looking at adopting pod security standards, and some implementation of that. Kyverno offers one built in. If you're not using pod security or any way of securing pods today, definitely take a look at Kyverno and the available policies, and I'll demonstrate that and how that works. So we also recently published a blog post, right? So on this, which covers this topic in a lot more detail. So if you're interested in that, go to nirmata.com, and there you'll see the blog post on Kyverno and PSPs. But let's kind of go to the demo and let's take a look at some of this in action, right? And certainly, again, as questions and stuff come up, let me know. But otherwise, what I'll do, let me check and see if I cleaned up after my last demo. Yes, looks like I did. So I don't have Kyverno installed. It's not, nothing's running here. I have a couple of namespaces. Seems like I have Nginx. I have a test namespace. Not sure what I was testing there, but there's something running in it. All right, so I'm going to go to the Kyverno IO site, and we'll head over to documentation, and I'll click on install. And what I want to do, so you can install through Helm, which Helm is a package manager for Kubernetes. But I'm just going to do the install kind of the YAML way through this command line, right? So I'm copying this command. and we'll apply it into my cluster, which should pull down a bunch of definitions. And now if we go back and check our namespaces, what we'll see is I have a Kyverno namespace created 7 seconds ago. If I do, let's do -n Kyverno, and we'll say get pods. I should see the Kyverno. Oops, let me get that command right. So the Kyverno pod is up and running, which is good, and everything's, it's already installed. As you saw when we installed it, also pulled down a bunch of custom resources. It created some roles. So a number of different things happen. The docs cover this in a lot of detail, so feel free to take a look. But at this point, if I now do, kubectl get, and cpol is just a short for cluster policy, it'll say no resources found. So Kyverno is installed and running, but there's no policies that I have defined. So what I'm going to do is go back to the Kyverno site, and we see this tab called policies. I'm going to click on that, and I see pod security, right? So I'll click there, and it's telling me, hey, to secure your cluster based on pod security standards, apply this. So let's grab that command, and we'll go back to my cluster. And what I'm going to do is just pull down, the pod security policies predefined in that Kyverno library. So while it's doing that, just going back to the page, you see there's tons of other policies. So definitely, if you're looking for best practices, things like that, this is the first place to come to. And you can see there's about 60 policies defined with multiple rules. They cover like generate, mutate, validate, and the community is constantly adding more, right? So this is we get every new release, we get about at least 10 plus more policies based on examples and things like that. And all of these policies also get tested. So just again, thinking about production deployment. So as Kyverno gets built, we test with these policies to make sure they're backwards compliant and things are still operated. Okay, so going back to my cluster, I see that now there's a bunch of policies installed. And if I go back and do that get cpol, I see now I have about a handful of policies, all seem to be doing things around pod security, and they're all set to enforce, right? So now let's try and do something. If I were, let's say, trying to hack into a cluster, and there's this pretty good, interesting site. I can link to that for folks. It's something called Bad Pods. It shows things you should not have running in your cluster. So you shouldn't have pods running with privilege mode, or where they can access the host bid namespace, or if they can access directory and file systems on your host, or the host network, or even the host IPC namespace, right? So these examples are like wide open, things you should really not allow, right? So what I want to do is I want to grab this worst possible pod and see what happens if I try to install it in my cluster, right? And as you can see, it says denied, Kyverno denied the request. And there's a bunch of errors it showed me that I need to fix before I try to run this, this pod in my cluster again, right? So it's saying that you cannot run in a host namespace. This is bad because if somebody does get access to your pod, from there they can, kind of do basically break out of the container, access your host, and then start, looking for other sensitive information on your host or other ways to kind of penetrate or attack systems within your environment. Same thing with host path, right? If you mount like things like, if I can mount proc in my container, I can see what other processes are running. I can start doing some interesting or malicious things in that environment. Privilege containers are bad because if I'm running with privilege, I can sort of go to root user, and then again, if I break out of the container, I have access to things on the host as root as well. Similarly, requiring run as non-root is important. So that's another thing that got enforced, right? So the good thing is the worst possible type of pod you could run was blocked, and all of these rules were applied through Kyverno itself. And that's just as you can see in about 5 or 10 seconds, just by pulling down the set of default policies, I went from an insecure cluster to a pretty well configured or well, reasonably secured cluster, there's more things that you would want to put in, but at least the basics of pod security in this case are covered. So I want to kind of show one more example of a policy in Kyverno, and this is a very different policy example. What I want to show, and we'll just look at this in my Visual Studio code. As I mentioned, by the way, if you're running Kyverno and once you have it installed, Kyverno has a set of CRDs, right? So if I want to look at anything, if I, let's say now I want to get help on how to write a policy, I can just do kubectl. Kubectl is the command line for Kubernetes. I say explain and I say policy, and if I just do policy, it'll tell me, hey, this is what a policy definition is. Then I can see that it has something called spec. And I know spec has rules, so I'll just kind of go a little bit deeper and it'll show me all of the help for it. If you're using Visual Studio Code, it will also, with the Kubernetes plugin, it will also kind of give you the help, the syntax, etc. So this policy that I have over here, it's a slightly more complex policy, but the interesting thing here is it's saying that, make sure that in every namespace, I only want one service of type load balancer. So here what we're doing is we're making an API call in the policy. So during admission controls, Kyverno will make an API call to the Kubernetes database. It will check and see if that namespace already has some services. And then it's going to use JamesPath, which is a way of evaluating JSON, to check and see that the length, the number of those can be exactly one. So the rule is now, once we have done those, those calls, the rule over here is to say, hey, make sure your service count equals one, right? So pretty straightforward once you kind of understand how this, API call is made and how we are processing it. So if I, just to kind of test that policy, what I'm going to do is let's apply this policy. So I'm going to copy the path. Let me make sure I got the actual path and not the relative path. And we'll do kubectl create -f, and I'm going to type in that path. So it created that. And now what I want to do is I have an example of a resource here. So I'm going to copy path to that, and we will do create -f on that resource. So the first one is allowed, right? Because we want to only block when there's two. But the next one, if I try to run it as expected, it's going to tell me that, hey, you can't do that because my admin wants to make sure that each namespace has a single load balancer service. Now, this is just some, this is a rule that you may or may not want to impose. It's a best practice because it makes sure that each application is in its own namespace. But a good example of how flexible Kyverno is in being able to program these policies, right? So hopefully that gives you a quick idea of what Kyverno can do, how powerful it can be. There's several other example policies that we won't have time to go through, but I encourage you to kind of look at the policy library and reach out on and I'll share some links to our community forums and where you can kind of reach out for more information, right? So just to kind of summarize and wrap up, right? So policies can be used for validation, for automation, for several other use cases to really complete that Kubernetes experience. And because Kyverno is built for Kubernetes, once you learn Kubernetes, which has its own learning curve, of course, but once you're there, Kyverno makes it very simple. And you can, apply, you can start with things like pod security, but then move to more advanced policies. And of course, as you saw, like the installation using Kyverno is pretty straightforward, very simple. So definitely, if you haven't tried it yet, go ahead and give it a try. There are a lot of, policies. Notice sample is spelled wrong. Let's fix that as we are going through. But there's a lot of bunch of policies that you can start with. Certainly the pod security ones, again, would be the right set because they are based on standards from the Kubernetes community, but take a look at the best practices, reach out on the Slack channel in the Kubernetes Slack, or if you just go to our GitHub page, you'll also see, there's help and discussions there. And finally, at Nirmata, what we're also doing is we're building So like we talked about with declarative policies and declarative configuration, ideally you want to report and manage this across a fleet of clusters and your CI/CD pipelines. And that's what the Nirmata's policy manager solution does. So if you go to nirmata.io or nirmata.com, you will see some information on this. There's free trials you can sign up for and use this with Kyverno. You get nice reports you can share, and you can drill down and see exactly what's going on. So just makes it easy to use Kyverno and scale Kyverno in your environments. So that's what I had prepared for the presentation, and we just have a few minutes left. So happy to take any more questions or go deeper. And I do have time to stay on even after the hour. So happy to do so based on any topics.
And as always, feel free to drop it in the chat too if you're feeling shy.
Hello.
Hey there.
Yeah.
Thank you for that presentation. So this is Sung-Soo from the Akinox company. So I have one question. So if there are multiple Kibero polishes, how to handle the polish conflict? So is there any priority value for each polish where, I'm wondering how to handle the conflict.
A good question, right? And so the way Kyverno is designed is each policy is atomic itself. And you can have policies at the cluster level and also at a namespace level. But either a policy passes or fails atomically. So it's designed so that it doesn't allow you to override other policies or create conflicts. Now, you could end up if just like with any tool for automation, you could end up with things like maybe you're generating resources and then Kyverno tries to mutate them. And if it tries to mutate them again, it'll be a no op in Kyverno. But you could end up with some situations where you create like a generate loop, things like that, right? So there are things to check against those basic errors. But of course, when you're programming things, you have to also kind of use some best practices and test it out in a test cluster to make sure that those type of things get avoided. But in terms of the conflict, it's designed so that each policy is atomic and either it applies and it passes, or if it doesn't match, it's basically ignored for that particular admission request.
Oh, okay. Thank you for the answer.
Sure.
Nothing else in the chat at the moment. Give it a short count before we wrap it up. All right. Jim, that was an awesome presentation. Really appreciate it.
Thank you. Pleasure.